So this article is related to graph neural network based voltage stability prediction in large scale power system, and it means that 1,000 bus network approach in MATLAB. So in the graph neural network, we shortly called as GNN based approach for predicting the voltage stability in large scale power, and 1000 bus network is basically used to test case with known features including the active and reactive power injections as well as the voltage magnitudes. The GNN model is basically trained using a supervised learning approach with the goal of predicting voltage magnitude across the network. Results proposed approach achieves a high accuracy with a mean square error of 0.0012 pico unit. Okay, pico micro. So the model performance is evaluated using the matrices such as voltage prediction error and stability margin. The proposed approach is basically scalable and can be applied to large power system as well. So the GNN ability to capture the complex relationship between the network components and enables the effective voltage stability prediction. So I have written the abstract with the keywords of introduction. Introduction I have added like how traditional method for voltage stability assessment rely on model-based approaches which are computationally intensive and are often impractical for large-scale system as well. So this is the GNN based voltage stability prediction at 1000 bus power network, which I have added like how true versus predicted voltage, GNN training loss, predicted voltage profile, and voltage prediction error histogram, voltage stability, and load versus voltage, sorted voltage comparison according to and the voltage stability margin. Okay, so I have added everything, the explanation in this paragraph. The background and motivation is that GNS has successfully applied to various power systems problems, including state estimation and fault detection, the increasing availability of data from smart meters and phasor measurements units as well, PMUs. Okay. So the graph neural network overviews that it is just an explanation like how the GNN successfully applied to various power systems and how GNN provide us the relationship between the network components, making them well suited for power system analysis as well. And 1000 bus is basically contains the 1000 bus system which each with active and reactive power injections and voltage magnitudes, and how the edge features include line impedances and admittances. The network is simulated using a power flow solver to generate a dataset as well. So architecture is GNN is architecture used for voltage stability prediction consists of multiple graph convolution as well. So the GNN architecture basically used for voltage stability prediction consists of multiple graph convolution layers. So these are the GNN architecture as well parameters. Data generation, training GNN models as well. These are the parameters used for training parameters, performance matrices, future work as well, and the problem statement is written mathematical approaches that these are the neighboring nodes according to the formulation of convolution neural network. In this formation, the weight matrix at the each graph convolution layer is set for trainable parameters that controls how information from neighboring nodes is added. So these are the methodology with the design, MATLAB simulation and analysis, and the GNN training loss plot, true versus predicted voltage profile, voltage prediction error histogram, voltage stability classification, load versus voltage, sorted voltage comparison, voltage stability These are the results and discussion with the conclusion. And let me just provide you MATLAB demonstration. This is a MATLAB. You just need to run this and you will get the output results accordingly. See, these are the output results: voltage stability margin, sorted voltage comparison, load versus voltage, voltage stability classification, voltage prediction error histogram, predicted voltage profile, true versus predicted voltage, GNN training loss. Okay. So if you need to ask anything, you just ask me. I will answer your questions. Thank you. This article, let me explain to you all the code interpretation for GNN based voltage stability prediction 1000 bus power node network. So these are the clear CLC close or means clear and the command window, clear the workspace, clear means workspace clear, CLC command window clear and close all the figures open previously. So these are the system parameters which I have defined in the paper as well. These are the running of GNN. It just print the graph. Let me just, for example, let me section by section run it. Control plus enter, and we will run only this section only because this section is separately. And let me run this, and it will print the like the running GNN voltage stability prediction here. This is a network topology, all the parameters used in it, node features and true voltage values, DL variables as well, all the defined variables here, training of watches according to the for loop, and in which I have defined all the learning rate with the W1, B1, W2 and B2 as well, loss history as well. Prediction, these are the prediction equations for the minimum of velocity. These are the plot for training loss according to the labels of X, Y, title and grid down for the plot commands. Then this one is the true versus predicted voltage accordingly, then predicted voltage profile and the voltage error distribution. This plot is for plot 5 is stability classification, then plot 6 is load versus voltage, and true versus predicted voltage. Yes, true versus predicted sorted voltage comparison, and plotted is stability margin. Then functions I have defined, these are the functions for the model loss, and according to the voltage of predictive voltage loss values of gradient and G gradients with this W1, B1, W2, B2 values. This function defines for the GNN forward values according to the voltage prediction values. Okay. So when you will run it, you will get the output results accordingly. Okay. Thank you.